Good morning. The previous section we have already discussed about the spectroscopic techniques of the AIS atomic absorption spectroscopies and the flame emission spectroscopies, which have already discussed. Next we are going to take about on the topics of estimation of hardness by EDTA method. We are conducting the EDTA method for using the samples titrations for estimating the amount of hardness present in the given water samples. So that is the chemicals required is standard hard water, that is 1 gram of calcium carbonate plus dilute HCl made up to 1 liter of the solution. EDTA solution 4 grams of EDTA solution salt per 1 liter of the water. EBT indicator, that is 0.5 gram EBT is 100 ml alcohol. Ammonia buffer 67.5 gram ammonium chloride plus 570 ml ammonia made up to 1 liter. So this is the apparatus required to use it to determine the hardness by EDTA method. Next, the ammonia buffer solution, which is the starting agents. The hardness is estimated by a complexometric titrations using two ligands, namely ethylene diamine tetraacetic acid, that is EDTA, and erythrome black tea. EDTA is insoluble in water and hence its soluble form of disodium salt is used as a complexing agents. So by this is the substance which have been using as a EDTA. Here the structures we have been shown that EDTA CH2CH2N with the bond of CH2COH acid, CH2COHNA and CH2COH2 acids, CH2COONA. This is the reaction which it forms the structure of EDTA. So the principle which is involved in the EDTA process is, as indicated above, the amount of hardness causing ions, calcium and magnesium ions, can be estimated by titrating the water samples against EDTA using erythrome black tea at pH 8 to 10 in order to maintain the pH. A mixture of ammonium chloride and ammonium hydroxide was added. So by the nature, the erythrome black tea is blue in color, where EBT indicator is added to water sample. It forms a wine red colored unstable calcium magnesium EBT complexes. So from these complexes, it will reactions carried out under the basics of pH 8 to 10 using an ammonia buffer solutions. So by using this ammonia buffer solutions, the reactions can be changed according to their color presence. So next, the calcium or magnesium plus EBTA gives calcium magnesium plus EBTA. So when EDTA is titrated against the complex, EDTA replaces all the EBTs and forms a stable calcium magnesium EDTA complexes. The liberated EBT indicates the end point as a steel blue color. So this is the end point reaction which occurs at the from steel blue to color solutions. The reaction occurs under the order of a wine red to steel blue when the reaction has a calcium or magnesium EBT plus EDTA gives calcium magnesium EDTA plus EBT, that is the steel blue color forms. So that the end point in the color changes from wine red to steel blue has a formations. So here the short procedure which have been shown in the diagram, that is the content. Titration 1 standardization of EDTA, titration 2 total hardness, titration 3 permanent hardness, burette EDTA, that is standard hard water, and the additional solution it should be a 10 ml of ammonia buffer, indicator EBT, endpoint wine red to steel blue, and the volume is a V1. And the titration 2 it has a total hardness, standard EDTA, sample water, 10 ml of ammonia buffer, EBT, wine red to steel blue, V2. Titration 3 permanent hardness, standard EDTA, boiled water, 10 ml of ammonia buffer, EBT, wine red to steel blue, that is V3. So this is the procedure how the reactions can be carried out by using the substrate. So the calculations, how we calculating the step 1 is standardization of EDTA, that is 1 ml of standard hard water equal to 1 ml of calcium carbonate, that is given solution. So 20 ml of standard hard water equal to 20 ml of calcium carbonate. V1 ml of EDTA is required for 20 ml of calcium carbonate Therefore, 1 ml of EDTA equal to 20 by V1 milligram of calcium carbonate. Step 2. Finding the total hardness. 20 ml of sample water required equal to V2 ml of EDTA. V2 x by V1 20 ml milligram of calcium carbonate. Therefore, 1000 ml of sample requires equal to V2 into 20 into 1000 milligram of calcium carbonates by V1 into 20. So total hardness equal to V2 by V1 into 1000 ppm. And the step 3, finding that the problems of 20 ml of boiled water required equal to V3 of EDTA, V3 by V1 into 20 milligram of calcium carbonates. Therefore, the permanent hardness V3 by V1 into 1000 ppm. The step 4 is a temporary hardness equal to total hardness minus permanent hardness. So total hardness which is to be used in the hazard sections, and it has a total values which should be mentioned in the values of ppm. So this is the process which have been described for determining the estimation of the amount of hardness by using these water samples. Thank you.